So here we are, trapped at home in the lockdown because of the COVID-19 crisis, and I want to practice making some video. So here I am. A friend of mine tweeted about a JavaScript function called reduceRight, which is on the array object. And he was kind of intrigued about the difference between reduceRight and reduce and what the difference between these two methods was. So we're going to look at what these do. Essentially, reduce takes an array of values and it reduces it into a single value. And the way that it does that is you create a function. This documentation is using new JavaScript syntax. This is the call to reduce here. So we've got an array, which is 1, 2, 3, 4, and we're going to call array1.reduce, and we're going to pass it this reducer function. The reducer function is in short function syntax here, which hopefully you're familiar with. And the function takes two parameters, an accumulator and a current value, and then it does something with the current value and the accumulator, and it applies. So we start with 0 effectively, and it takes each item in the array. So it takes 1 as the current value, and then in this case adds it to the accumulator, which has started at 0. So the first time it's called on 1, it returns 1, and then that 1 that's returned gets carried into the second iteration of the reducer. So the accumulator is now 1 and the current value is now 2, and so we will return 2 plus 1, which is 3. The accumulator is now 3 for the third call, so we make the third call with an accumulator of 3 and a current value of 3. They're added together and we get 6, and then the accumulator is now 6. So for the fourth item in the array, the accumulator is 6, the current value is 4. They get added together and returned, and that returns the final accumulator value of 10. And so the effect of calling the reduce here is to return 10 by adding all these numbers together. What reduceRight does is it does exactly the same thing. The example here is really different. It does exactly the same thing, but it runs from right to left through the array instead of from left to right. And the question is, why is this different? So let's go into Firefox here, and let's make an array. And this is an array of 5 numbers, 1, 2, 3, 4, and 5. That's great. So we can call reduce on this, and we need to pass it some function. So we'll also use the short syntax. And it was accumulator and item. So it'll take the accumulator and the item, and then we'll just do the basic operation of returning the accumulator plus the item, and this will sum all of the items in the array. So we should get back 15 for 1, 2, 3, 4, 5, which is perfect. And then reduceRight actually gives you exactly the same result. And this happens with addition, and it happens with multiplication. So that's reduceRight, gives us 120, and reduce also gives us 120. So what's the use case for this working differently? And to explain this, I want to explain that some operators and functions are what's called symmetrical and some aren't. So a symmetrical function is one where it doesn't matter what order we put the operands into, or the function parameters into. It will always return the same. So if I do 1 plus 2, that's 3. And if I do 2 plus 1, that is also 3. So this works for addition, and it works for multiplication. So I can do 2 times 3 is 6, and 3 times 2 is also 6. It doesn't matter which way around they are. And actually you can string things together in order like this. 1 plus 2 plus 3 is 6. 1 plus 3 plus 2 is 6. Because the order of any 2 doesn't matter, the order of any combination also doesn't matter. And this also works with 3 times 2 times 7 is 42. 2 times 7 times 3 is also 42. So there's this symmetry, the idea of it doesn't matter which order you pass the parameters in, you'll always get the same thing. And we can do this with functions too. So let's say we have a function called add, And we'll see this works. We're just going to do some simple addition here for sake of argument. We're going to have two parameters to this, x and y, and it will return x plus y. And this function also has symmetry. Oh, that didn't work. Let's do add equals function of x and y. That's better. So we can now add 3, 2, and that's 5. And we can add 2 and 3, and that's also 5. Now what's interesting about this is you can make this principle very generic. You can class any function with two parameters as being symmetric or not symmetric. So, and another thing that we could do is we could actually demonstrate symmetry by swapping over the parameters like this. So we've now got a function of y and x, and again, if I pass those, this all makes perfect sense. It just doesn't matter what order things are in, it always happens. Let's look at something that doesn't work like that. Let's look at concatenation. So with concatenation, if I do a plus c, this is all in JavaScript, I get ac. Now if I do c plus a, then I won't get ac. I'll get a different result. I get ca. And this function is therefore not symmetric. Equally, we could do concat equals function of two things, and we return those two things concatenated. And then if we concat, oh, let's concat something else. Hello and world, we get hello world. But if I define this function with the parameters the other way around, and then call it the same way, we get world hello. So this is not a symmetric function. And any function with two parameters can have this symmetric property where it doesn't matter which way the arguments go. This is a kind of mathematical idea, but it really applies to this idea of reducing in one direction or reducing in another direction. Because if you reduce right, then you're effectively swapping, or you're treating the parameters in a completely different order to how you were treating them before. So if we do an array like this and reduce this with the accumulator and the item, return a plus I. Okay, so this will give me A, B, C, D. It just joins the array together. But if I swap these over, you'll see I get it backwards. I'm not going to go into detail of exactly why that happens, but it's basically putting the new thing in front of the old thing, or the old things. But this is also true for reduceRight. So if I put the parameters back the right way around, but reduceRight, then I get the same result. So because concatenation here, this is not symmetrical, it does matter which order you pass the operands in. Or for this function isn't symmetrical, you could argue, and so it does matter which order your parameters are. Because it's not symmetrical, that's why reduce and reduceRight behave differently. We'll see this with numbers, with other types of operations. You'll note that 1 minus 3 is minus 2, and 3 minus 1 is 2. And so this minus operator is also not symmetrical. So if we do 1, 2, 3, 4, and reduce that with the accumulator and the item being, what should we do? Accumulator minus the item, then that gives us minus 8. And if we reduceRight, because this operator here is not symmetrical, it does matter which way the arguments go, we're going to get a different result. We're going to get minus 2. And division works like this as well. And any function, as I say, where it matters which order the operands go in, what result you get, that's when you're going to get a different answer. So this idea of symmetry is really important for reducing, and hopefully it explains the difference between reduce and reduceRight, and why you could have some huge long function with two parameters, accumulator and something else, which does something really complicated, but where it doesn't matter which order these things go in. It's the fact that these can be swapped without changing the meaning or the result that you get. That's what determines whether or not reduce and reduceRight behave the same or not. I don't know if this was helpful. It was interesting to explore these two functions and the idea of symmetry. Thanks for watching.